Hello U10s and welcome back to mathematics. In today's lesson we're continuing with our topic of linear relationships and we're looking at a thing called the gradient-intercept form. So for today's lesson our learning intention is to explore the gradient-intercept form for a linear relationship, and by the end of this lesson we want to be able to do three things. One, we want to be able to identify the parts of the gradient-intercept form. Two, we want to be able to graph a line using the gradient-intercept form. And three, we want to graph special lines after as well. So the gradient-intercept form, what is it? Now, here I've got a quick definition. The gradient-intercept form is the equation of a straight line where y is the subject of the equation. So here in this topic of linear relationships, so far we've actually gone and at the beginning of this topic we graphed a whole bunch of lines on a Cartesian plane, and the way that we did this was we filled in a table of values. And so what we're doing here is we're looking at a particular way that these rules are written, and it's called the gradient-intercept form. Now the gradient-intercept form, they all follow the same pattern, and this is what the pattern is. It's written as an equation, y is equal to, so the equation, we've got an equal sign, y is equal to mx plus b. Now m and x are just two numbers, so these are numbers that can change depending on the question. So the gradient-intercept form is just in this particular pattern, follows this particular pattern. Y is equal to mx plus b. Now there's a reason why I've highlighted the letters m and b, and it has to do with what the name of this particular form is. The name of this particular form is the gradient-intercept form. And so m and b actually represent the gradient. Now, if you remember from 2 lessons ago, m here is just a gradient. Now, 2 lessons ago, we talked about what the gradient was. This is how steep a line is. So, steepness of the line. And the way that we actually calculated this, if you remember, was we used the formula m is equal to rise over run. And so we calculated the gradient using this formula. And the other thing is, well, based on this name, it's the gradient-intercept form. And so the b here refers to my y-intercept. Now, an intercept is just where our line touches a particular axis. And in this case, it's where the line touches the y-axis. Okay. So these are the two. This is why it's called the gradient-intercept form. In the gradient-intercept form, we get these two pieces of information put into the equation of our line. And so what we want to be able to do is we want to be able to identify the gradient and the intercept of a line just by looking at the gradient-intercept form. And so what we need to do here is we need to match up our equation that we get given and m and b, and just find out the value that we need to that each one of these match up to. So let's have a go at the question on this. So identifying parts of the gradient-intercept form. For the following equations, state first of all the gradient and also the y-intercept. So let's have a look at these 3 examples. The first one is y is equal to 3x plus 4. Now remember, the gradient-intercept form is just y is equal to mx plus b. And so what we want to do is we want to find the values for m and b. So if you have a look at this first one, y is equal to 3x plus 4. The first part, the gradient, so part I, the gradient, or m, if you have a look and match this up with my equation up here, the value of m is just going to be the 3 in front of the x. So here m is going to be equal to 3. So my gradient is equal to 3. The second part is my y-intercept. So I just match this up again, and if you notice here, it is plus 4. So my y-intercept, I'm going to write it as y-intercept is equal to 4. So all we're doing here when we're identifying the gradient and the intercept, all we're doing is just matching our equation up with the gradient-intercept form y is equal to mx plus b. Okay, part 2. So y is equal to negative 3 over 4x minus 7. Once again, here, we're just identifying and matching up the parts of my equation with my gradient-intercept form. So here, the first part is we've got y is equal to negative 3 over 4x minus 7. Okay. So, m is going to be the number before the x. Now here, notice there's a negative as well. So when I've got a negative sign, I need to actually include that negative sign as well. So it's not just going to be 3 over 4, it's going to be negative 3 over 4. Okay, so that's the first part, finding the gradient of this line. The second part is then I want to find my y-intercept. Now here, you might be going and looking at this equation. Well, I'm just going to look at the number, and so that means that my y-intercept is going to be 7. Now, unfortunately, that is not going to be the case. The reason being is if you have a look at the gradient-intercept form that I wrote up the top here, it's y is equal to mx plus b. Now here, because I don't have a plus sign and it's actually a negative, I need to include that minus sign as well. So here, my y-intercept is not just going to be 7, it's actually going to be negative 7. Negative 7. Okay, so that's how we answer this second one. We need to also include the negative signs if they're included inside our gradient or our y-intercept. Okay, final part is this one here. C, y is equal to x. Okay, C, y is equal to x. Now here, the first part, the gradient, well, if you have a look at the x, there is no number that is before my x. But if you remember when we talked about algebra, there's actually a hidden coefficient if you ever see a letter by itself. If you ever see a letter by itself, that means there's a hidden coefficient of 1. So here, my gradient is actually going to be 1. So if you ever see a letter, so here in this case, x just by itself, that without any number before it, that means that the hidden coefficient is 1. Or hidden gradient is 1 in this case. Now the next part is the y-intercept. Now the y-intercept, because there's no number there, that just means I have a y-intercept of 0. Okay, so that's this first part. When we are finding the gradient and the y-intercept, all we want to do is just match up our equation with that form y is equal to mx plus b. And just from there, we read off what is m and what is b. Okay, that's the first part of this today's lesson. The second part is we want to be able to sketch our line using this gradient-intercept form. So that's what we're going to do in this next part here. So once we've been able to identify our gradient and our y-intercept, what we can do is we can actually sketch this on our Cartesian plane a lot quicker than actually creating a table of values. So here, this is the step that we want to follow. Step 1. When we're sketching with the gradient-intercept form, the first step is to identify the y-intercept. So just like we did in the previous part, y-intercept and the gradient of the line. So the first step that we want to do is we want to just write out what is the gradient m, what is the y-intercept, and b, and just match it up. Then what we do is we are going to plot the y-intercept on the y-axis. So once we've found what the y-intercept is, we go to our y-axis and then we put a dot at where that value is. Then the following step is then we use the gradient to find another point. Now just remember the gradient is just rise over run. And so what we can do is we can move across the x-axis the amount of units in the run and move up and down the amount of units in the rise, and that will give us a second point to put on our Cartesian plane. And then once we've done that, we can just draw a straight line through the 2 points. So let's have a go at an example of this. This is example 2, drawing a line using the gradient-intercept form. So we want to sketch the following graph. Y is equal to 3x plus 2. First step, let's identify the gradient and the y-intercept. So the gradient is just m, and in this case, the gradient is this 3 here. So I'm going to write here, m is equal to 3. My gradient is equal to 3. Second part is my y-intercept. So my y-intercept is just going to be the value which I'm adding at the end, which is just, in this case, 2. So my y-intercept is 2, my gradient is 3. Once I've done that, let's go through plotting this on my Cartesian plane. So I'm going to just draw up my axes here. Okay, so I've got my Cartesian plane here. So I've got y and, let me just try that one again because I realize it's a little bit off. Shapes. This guy. There we go. Okay. Y, X. I'm just going to put in my, so the first step, I've just created my axis. Okay, cool. Let's try that again. What we're going to do now is we're going to plot on, the second step was we're going to plot the y-intercept on the y-axis. So my y-intercept is 2. So what this means is I'm just going to go to where 2 would be on my y-axis. Now I'm going to make 2 over here. Now, I know the grid is I'm going up by 1s, but in this case, I'm just going to make it go up by 2s each time. So 2, 4, 6. I'm going to go 2, 4, 6, 2, 4, 6, and the same here. Negative 2, negative 4, negative 6. I realize I should put some negative signs here. Okay. So I'm going to put a dot at that y-intercept of 2. I'm going to put a dot at that y-intercept of 2. Okay. That's the first step. I put a dot at the y-intercept. The second step is then I use the gradient to help me find a second point. Now the gradient here is 3, and so what this 3 tells me is that if I move across by 1 unit, I'm going to go up by 3 units. So here what I'm going to do, and I'm going to do this in Galaxy Pen so you don't have to copy this down, I'm going to go across by 1 unit, so that means I'm going across to where 1 would be, which is halfway along here, and I'm going to go up by 3 units, and I'm going to go, so if I go up by 3, I go up to 5. So here I'm going to go up by 3 units and go to 5, and so here I've got a second point. So this is 5 and this is 1. I've got a second point that I can plot on my Cartesian plane. And once I've done that, all I need to do is just draw a straight line through this. So here I'm just going to go grab my straight line and just draw a straight line through these 2 points. I'm going to zoom out a bit just so I can get this drawn out fully. So there we go. That is how I can draw my graph of y is equal to 3x plus 2. So let's just recap the steps that I did here. When you want to draw a line, a line that's in gradient-intercept form on the Cartesian plane, the first step we want to do is identify the gradient and the y-intercept. So just like we did in the examples before. Then the second step is then we put a dot on the y-intercept where the line touches the y-axis. So here, because the y-intercept was 2, I went to my y-axis at 2 and then put a dot there. Then, using your gradient, we're going to figure out another point. So here my gradient was 3, so I went across to the right by 1 unit and then up by 3. That's what the gradient tells me. And so I found a second point and I drew the line straight through those 2. So that's how we find in the sketch a linear relationship using the gradient-intercept form. Okay, now the next part of this lesson is we want to also be able to sketch a few special lines. There's a few special lines that don't fall into the gradient-intercept form that we still want to be able to sketch. And so that's what we're going to be going through with these examples. And I'm going to go through the examples and explain to you what these graphs actually look like. So here we've got 3 special graphs. And these are the, for this example, we're going to go through these ones. The first one, so here, sketch the graph of these equations. The first one is y is equal to 2. Now this, as you notice, is not in the form y is equal to mx plus b, but we can still sketch this regardless. So here, I'm going to draw out my axes. Now, here we've got y is equal to 2. Now, if you think about it, y is equal to 2, I'm just going to find the point where y is equal to 2 on my Cartesian plane. That would be on the y-axis. So I'm going to go to the y-axis and find the point where y is equal to 2, which is over here. Now, when I see the graph y is equal to a number, if I ever see y is equal to a number, so let's say a, what this will mean is that there is a whole bunch of points where y is equal to 2. And it actually forms a horizontal line. So if you ever see the graph y is equal to a number, this is just a horizontal graph at wherever that number is. So here, this graph here, if I draw a horizontal line at y is equal to 2, this guy here is y is equal to 2. This whole line is y is equal to 2. Okay, that's the first one. Now the next one is b. X is equal to negative 3. So I'm going to once again get a Cartesian plane up. And so here I'm just going to draw out y, x. And once again, I'm just going to find where x is equal to negative 3 on my Cartesian plane. Now, x is equal to negative 3 is on the x-axis, and it's going to be at negative 3. So I'm going to go all the way out here to negative 3. Now, if you ever see an equation in the form x is equal to a number, so let's say a number b, what this is going to form is instead of being a horizontal line, like y is equal to a, it's going to be a vertical line at wherever that value is. So here at negative 3, I'm just going to draw a vertical line. And so this is what the graph of y is equal to x is equal to negative 3 will look like. So let's just quickly sum up with those two. If you ever see y is equal to a number, when we graph that on a Cartesian plane, that will form a horizontal line. Y is equal to a number will give me a horizontal line. If I see x is equal to a number, it's going to give me a vertical line. Okay, so those are the first two. Now the last one, we can actually use our gradient-intercept form to actually help me answer this last one. So I'm going to sketch this one out. I'm going to get my Cartesian plane actually. So here, get out my Cartesian plane. Okay. Now for this one, let's just actually go through the steps that you would do if you were trying to graph this using the gradient-intercept form. So here I've got y is equal to negative 2x. The gradient is just going to be minus 2. And the y-intercept for this one, well, there is no number, so the y-intercept is just going to be equal to 0. So let's put this on my Cartesian plane. The first step that we did was we plotted the y-intercept. Now y is equal to 0, it's just going to be on the origin. If I have a y-intercept of 0, that means it's just going to be on the origin. Then from there, we're going to use our gradient to help me find the second point. Now here, the gradient is minus 2, which means if I go across by 1 unit to the right, I'm going to go down by 2 units. So here, I'm going to use my Galaxy pen to get this. So I go across by 1 and go down by 2. And so my point is going to be over here. And so here, this is I'm just going to make a point here. This is negative 2, 1. Once I've got that, I can draw my line through these 2 points. And so this one is going to look something like this. If I can draw a line through them. Yep, there we go. That is what my line will look like. So this is the graph of y is equal to negative 2x. So for this one, we can actually still use our gradient-intercept form to help me graph this one. But what we needed to notice was that the y-intercept was equal to 0. And so that means that dot is going to be at the origin. So that is how we graph these special lines. So these are special lines because they only have one intercept. If you have a look at the previous example, we've actually got 2 intercepts here. So we've got a y-intercept here at 2, and we have an x-intercept here at roughly negative 2 over 3, I believe. Okay. So this is how we sketch our these 3 special lines. If you see y is equal to a number, that means it's a horizontal line at that y value. If you see x is equal to a number, it's a vertical line at that x value. And if you see y is equal to a number, a 2x, for example, or negative 2x, or a number times x, it's just going to be a line that goes through the origin. We can still use our gradient-intercept form to actually graph that one. Okay. The final thing we want to be able to actually do in this lesson is check whether or not a point is on a line. And so here, the note that I have is, if you want to check if a point is on a line, we're going to substitute that point into the equation. So we're going to substitute the x value of our point and also the y value of our point, so our x coordinate and our y coordinate, into the equation. And if both sides are equal, that means that that point is on the line. So let's have a go at an example of this. Does the point 3, negative 4 lie on the line y is equal to 2x minus 7? So what I'm going to do here is I'm just going to write my point. So I've got 3, negative 4. With this point here, I've got my x value of this point, or my x coordinate is 3, and my y value is negative 4. So if you remember from coordinates, our first number is our x coordinate and our second number is our y coordinate. So if x is first, y is second. Okay, those are my 2 numbers. So what I'm going to do is, with my equation, I'm going to replace x with 3 and y with negative 4. And if it makes sense, if our equation makes sense, then that means it is on that line. Now the way I'm going to do this is I'm going to actually break down my equation. So my equation is y is equal to 2x minus 7. What I'm going to do is I'm going to break it down into 2 parts. I'm firstly going to deal with the y over here, which is my left-hand side. And then I'm going to deal with my 2x minus 7, which is my right-hand side. So let's deal with our left-hand side first. So left-hand side. On my left-hand side, I just have I just have y by itself. Now, if I substitute my y value for my coordinate, so that y value is just negative 4, this just becomes negative 4 by substituting. That's all I need to do. Okay, so I've got my left-hand side. Now, the second part is I'm going to now do my right-hand side. Now, my right-hand side, I have this statement, so 2x minus 7. What I'm going to do here is I'm going to replace x with the x coordinate of my point. So here I'm going to replace x with 3. So I'm going to have 2 times 3 minus 7. So 2 times 3 minus 7. So let's just figure out what this is. 2 times 3, that gives me 6 minus 7. So that gives me minus 1. So that's what I'm doing with substituting the point into my equation. What I want to do is I'm going to substitute my y value on where y is, so on my left hand side, and I'm going to substitute my x value into where x is on my right hand side. Okay, Now that I've done that, what I want to do is I want to check what these two values are. So on my left hand side, I have -4, and on my right hand side, I would have what? -1. Now, if I put this back into my equation, what this would look like is -4 is equal to -1. Now, I'm not sure about you, but -4 and -1 are not the same number. So what this means is, because these are not the same value, what this means is, therefore, 3 -4 is not on the line y is equal to 2x minus 7. If the two values match up, that means it is on the line. However, because they don't match up, because they do not match up, what I can say is that this point is not on the line. So that is it for today's lesson. Let's just quickly sum up what we talked about in today's lesson. The first thing that we talked about was the gradient-intercept form. And the gradient-intercept form is just a way that an equation that we write a straight line in. And so in our gradient-intercept form, we actually have two pieces of information about a line. We have the gradient and also the y-intercept. And we can read it off quite quickly. And all we need to do is just match up where these two numbers are in my equation and match it up with where it is in the gradient-intercept form. Then we also talked about sketching a line using gradient-intercept form. And so what we did was we identified what the gradient and the y-intercept was, plotted the y-intercept on our y-axis, and we found a second point using our gradient and then drew a line through those 2 points. Then what we also did was we drew a few special graphs lines. So if you ever see the line y is equal to a number, it's a horizontal line. And if you see x is equal to a number, it's a vertical line. And if you have y is equal to a number times x, it gave you a diagonal line that went through the origin. And the way that we found the second point was we actually used our gradient. And the final thing that we did was we checked if a point was on a line. And the way that we did this was we substituted the x and the y coordinates into our line and just checked whether or not this actually made sense or if the two sides matched up. So that's it for today's lesson. If there's any questions, feel free to give me an email or send me a message via Google Classroom. I'm more than happy to try and help you. I am trying to get around to everyone's questions, so please be a bit patient with me with that. I'm trying to catch up with all of that. But until next lesson, Year 10s, I hope you guys are staying safe wherever you are. And that, and I'll see you guys in the next video. Bye.